Hey, and welcome, Gurus. I'm Chase, one of your Azure training architects here at A Cloud Guru, a Pluralsight company. Congratulations on making it to the section conclusion of the Azure Load Balancing section of this course. To wrap up this section, we're going to quickly cover a case study scenario so that we can kind of bring all those components we talked about for Azure Load Balancing in each of the video lessons into one total solution. And then we're going to use that case study scenario to review our load balancing concepts, review Azure Load Balancer as a service and some of its features, and then we're going to review the cross-region load balancing to kind of follow up on what we did in some of the demonstrations. So to get started for our Control-Alt-Suites organization, when we say review load balancing concepts, we're talking about the types of load balancing and the components of load balancing, as well as those rule types that we have for load balancers. And then when we're talking about reviewing Azure Load Balancer as a whole, we're talking about comparing internal versus external Azure Load Balancer, the features of the basic and standard SKUs, and the load balancer roles that we have available using Azure Load Balancer. And then we're going to review also the cross-region load balancing, providing us that global load balancing, as we remember from our demonstration, and the benefits that cross-region load balancing provides, like lower latency, regional failover for highly available load balancing solutions across the globe, and then some of the limitations that it has, such as that you can only use it for external load balancing and not private load balancing. So now that we've covered all those items we'll look at in review of our case study scenario, let's actually take a look at what we have here. Here we have two different regions, West US and East US, inside of the Azure Cloud. And in each of these regions, we have resources deployed. In West US, we have a Spoke VNet, and inside of East US, we have our Hub VNet. In our Spoke VNet, we have an Azure Load Balancer that is public-facing, balancing potentially to VMs or VM scale sets in its backend pool. And then we have the same thing inside of our Hub VNet, again, a public Azure Load Balancer balancing to VMs or VM scale sets. And behind that public load balancer, we have maybe a private load balancer that is being used to balance traffic from those VMs or VM scale sets in the backend pool to balance to a private resource that is then balancing between those resources in its backend pool. And maybe that's a database tier, and the public is our front end tier. Now, both of these, because they're public, have public IP addresses. And if we want to create a cross-regional load balancing solution for these public load balancers, what we can do here is set up that cross-region load balancing solution in a home region that's supported, as we saw in our demonstration, and it will have a public IP address as well, and those load balancers that are public will be in its backend pool so that we can send traffic coming through that global load balancer and balance traffic to those load balancers in the backend pool for it. Now that's our total case study scenario, so let's break it down into the different components that we want to review here. So first off, our load balancing concepts. The purpose of load balancing is to balance traffic between resources, specifically compute resources in the backend pool, and that consists of things like our virtual machines and our virtual machine scale sets. And we are offering up those services or those compute resources as a single endpoint using an Azure Load Balancer in our case for internal or external purposes, so private traffic or public traffic if it has a public IP address. The components of load balancing make up that front-end IP, be it public or private, or both, and the back-end pool, which consists of our VMs and VM scale sets in the case of Azure Load Balancer, and then the rules that we use to determine how we're going to balance traffic between that front-end and those back-end resources. And then we have our health probe, which is the final component that checks on the health of those resources running in our backend pool to make sure that they are available for serving our traffic. And if they're not, then they're marked as unhealthy instances and they're not used to serve traffic. And this provides us that high availability for those resources in the backend pool. Now, to get a step further into our rule types for load balancing concepts, when it comes to Azure Load Balancer, we have those NAT rules, and that allows us to do things like administration over SSH and RDP. But more specifically for NAT rules, we have two types. We have our DNAT, which is that traffic that is being natted as it comes inbound. And then we have SNAT, which is that traffic that is natted as it goes outbound. And as we saw in a previous demonstration, we can obviously change the behavior of that outbound traffic as well as the inbound traffic using those NAT rules. Then we have our load balancing rules, and these are the rules that allow us to balance things like port 80 or 443 for HTTP and HTTPS using TCP or UDP protocol. Then we have our HA port rules, which are those rules that allow us to open up all ports on our Azure Load Balancer for load balancing. And this kind of gives us an any-to-any configuration for load balancing, providing us even more high availability for our solution rather than just using a single port for a load balancing role. Now that we've got the high-level load balancing concepts covered, let's dive a little bit deeper into reviewing what we talked about in this section for Azure Load Balancer specifically. Azure Load Balancer is a layer 4 load balancing solution that we can use to regionally balance things, and it also provides that global load balancing as we saw for cross-region load balancing, and we use it to balance traffic, specifically in the case of regional load balancing, to VMs and VM scale sets in its backend pool. Again, we can do this regionally and globally depending on our circumstances. And we can also load balance internally for private traffic, like that traffic going to a database tier in our solution, or externally to public traffic, be that part of a web tier for our solution, as we see in the diagram. And then when it comes to Azure Load Balancer, we really have two major SKUs here that we focus on. There is a third SKU, but the ones that we focus on for the exam here are these two. The basic SKU, which provides us that availability for using VMs in an availability set in the backend pool, or VM scale sets. Now with the basic SKU, as we talked about, it's open by default, meaning we have to use a network security group to be able to protect that traffic because it uses a basic SKU public IP. That's why it's open. Then for our standard SKU, we have those VMs or VM scale sets. As long as they exist inside of the same VNet, they don't have to actually be in an availability set. And standard SKU is secure by default because it uses a standard SKU public IP. And also, standard gives us the additional functionality of providing HA port rules to allow us to have high availability load balancing on all ports for our load balancer. And our standard SKU provides us a 99.9% SLA. So this is the SKU we typically use for our production workloads, and basic is more of development and testing. Now that we've dove a little bit deeper into Azure Load Balancer, specifically the features, the SKUs, and what we can do with Azure Load Balancer, we're going to dive a little bit deeper into that global load balancing to review what we talked about in a previous lesson with a demo on cross-regional load balancing, which the purpose of this is to balance traffic across regionally deployed load balancers like that in maybe East US and West US. And we can provide a global load balancer in a home region to load balance traffic across multiple Azure regions. Now, the features of cross-regional load balancing are going to be mainly that it provides us that regional failover for load balancing. So if we have a load balancer go down in one region, it will just fail over to another region that it is load balancing for, giving us that high availability via the global load balancer. And when using a global load balancer, we also have reduced latency because we're serving from multiple regions. And it's important to remember that the features of cross-region load balancing using a global load balancer is that it is only available when using public load balancers that are in its backend pool. We can't do global load balancing and balance across regions for private load balancers. That's not a feature that is supported. All right, gurus, that wraps up everything we wanted to review for this section. Those are all of the details. Thanks so much for joining me in this section. I look forward to seeing you in the sections to come.